living on it. So safety is a top priority. It's more so ever than after Columbia and Challenger. They're not going to do something dumb and have them destroy the space station and kill the people there. So you must, basically, they're trying to force you to prove that you won't crash. And proving a negative is theoretically really impossible. It's really hard to do to make these people happy. So the certification process is really expensive and time consuming. There's no exceptions, not even your Boeing or Lockheed. I've had those executives tell me that they're not going to get any waivers and make it simple on them. It's hundreds of millions of dollars, many years. If you look at the ATV and HTV as examples, they're both 10 plus years in development. So this is the key business problem that CSI set out to solve, and which I'm going to show you. Okay, we solved this problem with a pre-certified ISS spacecraft. It's already built, giving you, very attractive economics. Already launched to orbit, very attractive, and is patented under our system. Next slide. Now, after we had developed this system, what we realized is we had reinvented intermodal transportation for space. And if you go look at what intermodal transportation with standardized container has done for Earth transportation, it's transformed entire industries. The one that we're all most familiar with is the big standardized containers that you can take off a big ship, put on to a train at the bay, just pick it up and put it over, and then move it and put it on a truck somewhere else. It's transformed the entire industry in many ways. There's books written about it, starting about a little over 50 years ago. But standardized containers are taking effect in many other industries, on air cargo, even personal home storage. A FedEx container is a standardized container. This is what we were doing for space. Next slide. So I want to have an animation here that's a picture's worth 1,000 words. This is worth 10,000. I think you may need to click it. No.
Is there sound for it?
No. So this is an example. We can use, and since it's a standardized container, go on many different launch vehicles. This is just one launch vehicle. It's the Atlas V. Okay, launched out of the Cape. But you pick your launch vehicle, and there's a dozen launch vehicles in the world that existing could plug in this architecture. It launches our cargo container, our standardized container, near ISS. Okay, there's the Centaur container. This one's got both internal pressurized cargo and external cargo, because that's what NASA's interested in. And then once it's near ISS, outside the safety zone, the existing prepaid, already certified Progress spacecraft leaves the station. It's got enough propellant to do that. It comes out and docks with our container. It thinks we're a space station, and in fact we are a small space station out there. This has done this hundreds of times using the standard interfaces, docking system, radar. It docks. And it has the pass-throughs in the container, and the other side of the container is a duplicate of the nose of the Progress. At this point, you basically have a stretched Progress, which is docked with the station hundreds of times, and it comes in and does so. So we have basically, using a pre-certified approach, solved the last mile problem. Next slide. Okay, here you can see the container up front. This happens to be no external cargo. But it's basically the same systems that are already off the shelf of Progress. Now, we can do a US system of this, but if we're going to use the Progress as our first tug, creating the first big value for space tugs, turning this into a space tug, we use the same structure, front and end, that's already off the shelf in Russia to package this dumb canister. Now, some of the key interesting things, we eliminate all the expensive parts from our part of the spacecraft. The engines, the avionics, the prop is all over here. This is cheap done structure compared to this. Okay, they're launched separately. It's basically, we turn the Progress into a reusable tug. We get reusable on-orbit economics. Okay, it's stretched Progress. Another way to think of this is plug and play with existing ISS. systems. Next slide. In our COTS proposal, our teammates, Lockheed Martin was going to provide the launch services, going to provide some Russian program support, and they were going to develop our plan and initial designs for an all-U.S. cargo path. We've been talking to other companies, but for giving NASA confidence that the all-U.S. cargo path would work, we had Lockheed. RC Energy of Russia. The people who did Sputnik, who put up Yuri Gagarin, who built most of their space stations, did Mir, and did the Russian side ISS, was our strategic partner, built the canister and responsibility for the tug. Oceaneering Space Systems, doing our cargo integration. They do that from initial design to manufacturing to taking it all the way to the station already. A leading company at ISS. Odyssey Space Research works with the ISS program and orbital operations. Is one of their key contractors for that. Ares, the former head of safety and misinsurance for space station, was on our team, and Ares. L3 Titan developed the software for robotic simulation analysis for grabbing external cargoes, was on our team. We had someone providing a revolving line of credit, and an International Space Brokers was going to be our insurance provider. Next slide. Here's, you can just see where all the pieces of our off-the-shelf technology are. Every piece is TRL-9, proven on orbit. We had a small tweak to the avionics. It's just going from Rev 16 to Rev 17 on the Progress software. And basically had to change a few connectors, cables, and that was about it, and you plug this into the system. Next slide. Just to give you, can this be done? Is this how risky is this? Look, example is that Russians been doing this for nearly 40 years for this technology. Soyuz and Progress derived from Soyuz, started about 40 years ago. But think about the ISS Pirs docking compartments already at the space station. It's basically a standardized container. It was taken to the ISS by a Progress bus. Okay, it's much more complicated in our container because it has an airlock. But it's a separate, was delivered to ISS on a Progress bus. You can stretch the container. Here's their ISS Science Power Platform sitting on the Energia shop floor. Probably may never fly, but they built this and it was ready to go. Next slide. Our container would be built on the Energia Soyuz Progress assembly line. Here's the containers right here, or versions of it. Next slide. Now, I talked about how intermodal has powerful advantages. Some of the details. Intermodal is much more efficient for space. For the same launch vehicle, if you just do the cargo as a percentage of the total mass of the payload thrown to space, we have a much higher percentage cargo. For any given launch vehicle, we are more efficient. Because you have to do engines and avionics and prop on a direct ascent. Totally integrated supply chain. We just aggregate the supply chain, and you pick your favorite launch vehicle, we will stretch this and get a much higher percentage cargo. Next slide. So we've done it parametrically, okay, and anything below the line here is basically less efficient for a whole bunch of launch vehicles for cargo. Okay, here's the Progress. It's about half the cargo for the same launch vehicle. If we use the Soyuz launch vehicle for a Progress versus us, we get much more cargo for Soyuz for the same launch vehicle. If you take the Ariane 5, they're over in here for their ATV. So basically, we're more efficient at all sizes in an apples-to-apples comparison. Next slide. So another advantage, and it's very important for this community which wants to have new launch vehicles, the moment you get a new low-cost launch vehicle, Falcon 5, Falcon 9, an air launch, long reach, you can plug them into the supply chain. That's by disaggregating the supply chain and adopting a commercial practice has powerful advantages. So here's existing launch vehicles that we could work with, and here's some emerging launch vehicles that could plug into our supply chain immediately. And this is also very flexible. If one launch vehicle goes down, you plug a different one in. Your whole supply chain doesn't become risky and dependent on one launch vehicle. Next slide. You can stretch the canister, put it on different things. So here's just a family for larger launch vehicles that we could do. Next slide. The internal accommodations you're using standardized cargo transfer bags and mid-deck lockers. We did all the engineering, and Oceaneering does this and is on our team, did this for us. Next slide. So I wanted to give a little history of CSI. And I mentioned before, we're a company that doesn't know how to say uncle, adapts, survives. In early 2001 and late 2000, I challenged my guys. I said, hey, our customers are dying in the commercial satellite constellations. We need to do something different. We came up with a very low-cost, low-risk cargo solution. We submitted the patent application in March of 2001. And the first thing I said to my guys, we're going to go to NASA. If they're not interested in this, we're not going to invest a dime. You know, we got better things to do with our lives than do anything. Well, this senior NASA executive loved it. And he started championing it within NASA and tried to take over the entire AAS program just to buy our service. And the AAS program was held by another part of NASA in Code R down at Marshall, which wanted technology. But he said, this is supposed to be about serving space station. I need this now. So in the end, Dan Golden sides with Code R and the new technology, and they kept it in AAS. So, but that Code R, Code M and the ISS program gave us a little study to validate that it could be done. And then in 4 months, they came back, yeah, there's no showstoppers, this could work. And a senior Code M executive said, this is the only concept for AAS that has any relevance for us. They thought they didn't care about any of the other AAS proposals, according to this executive. And then after this was all done, we won an AAS contract in spite of it being at Marshall, in spite of it using Russian technologies, and in spite of Marshall just wanting new tech, and we had none of that. We won it. We beat companies like Orbital and TRW and a number of the companies that, that emerging companies. And then Energia, out of our own money, thanks to our investors, gave us a final report saying, yeah, this is technically feasible, we can do this. What's next? Let's go do it. Next slide. What we found out is right after we signed our contract, NASA basically decided, we started hearing words that Marshall had decided to cancel the contract. Understand, until they told OMB, and OMB told us that, hey, there's only one company who can do this. And the executive was explaining why they were canceling it. So, and then months later, Code M, which is fighting with Code R, had a memo talking about how R could be used in a future contingency, like a Challenger or Columbia accident, and you get surge or resupply to the space station on an existing launch vehicle, keep the space station up, not go from 3 people to 2 people at the station, do real research at a space station. Then international space brokers did their risk assessment and said, yeah, well, this is insurable, looking at the data of how risky this is. We completed our system design review a year later. We were given high marks by NASA on that. They made an extension to keep it going. You know, CSI was marking this heavily in, even though they canceled it. 6-month extension on it, did some more work about recoverable down mass. In December of 2003, we were finally awarded our patent that we applied back in March 2001. Next slide. We kept on working NASA, and a senior ISS program manager told us, basically, I would buy your service right now, except I have 2 problems. He was ready to buy. He didn't want a competition. He said, 1, I don't have a budget. I can't take my existing budget. I don't have a budget to pay for commercial ISS cargo services. And what he said is he gets shuttle cargo for free. So we were basically competing for the shuttle. We had to beat free. And he said INA. He actually went to the highest level of NASA and got told to don't play around with INA. Even though there's some exceptions to get around it, said INA needs to be fixed. So we set on a path to fix INA and fix having a program, and had a marketing efforts that actually succeeded in both cases. The president announced, basically caused by White House OMB, a new program, and later we amended INA. So we completed all ISS contract work in January. Another senior ISS program manager said, you guys still have a leg up on everybody on the ProxOps, which is proximity operations, or the last mile to ISS. We started doing work with Lockheed Martin. They paid they paid us to do a study of our system on their rockets, and concluded we're 30% more efficient on an apples-to-apples comparison than their baseline, than the direct ascent system. Basically validating our assessment, which I showed you earlier about intermodal is more efficient. Last year in June, a senior ISS program manager told us, if RSC Energy is behind you, and he used the word owns it, but he says if they're on your team, they stand behind you, he says then I'm fine with doing this. We're happy. Next slide. Last August, a senior NASA executives at headquarters and SOMD, and you can see a story here. There's a fight between the space station, which is a customer and needs cargo, and other parts of NASA, basically said, we are not letting those crazy entrepreneurs anywhere near our space station unless they use the proven Russian automated rendezvous and docking technology. Last year, Congress approved and the President signed an amendment to the Iran Non-Proliferation Act, allowing commercial systems. I just want to give credit to Jim Muncie. Many of you know of Jim leading the successful effort to amend the space transportation laws to minimize liability to the suborbital companies. What you don't know and should all have credit is he led the entire industrial effort of many companies across the nation in amending INA. COT's final announcement finally comes out this January. We bid, turn in our proposal this March. In May, the COT's agreement officer tells us we were not selected for the next round. And we wanted to know why. We had an hour-long telecon. They basically said, you guys had a very good ISS proposal, but this wasn't really what it was about. What happened in the last few months, the COTS program basically evolved away from being about ISS cargo delivery, and you can go see the Space News article where I talk publicly about this that's posted today. And it's turned into an U.S. industrial development program and more focused on crew than cargo. So in that, they use these three broader industry goals in an announcement to make that happen. Next slide. So I want to deal with something up front. You go, well, you guys are stupid to use Russian technology. And we proposed evolving to U.S. technology, and the moment there is a proven last mile spacecraft, whether that's the T-Space vehicle or someone else's vehicle, we think we can make them more efficient. But betting on an unproven technology, we think is, from a commercial perspective, is a bad way to go. And we basically adopted best commercial practice as a systems integrator. Okay, we're going to outsource to get the best value, okay, wherever we can get it. Okay, and some examples how this happens in a free market is, just think of the Boeing's doing on their 787. Their big new project has 300 Russian engineers. They're upgrading the 747 cargo capability, 200 Russian engineers. The only successful commercial launch vehicles, U.S. commercial launch vehicles that are sold by U.S. companies, use Russian technology. You go look at Sea Launch, you go look at Lockheed selling Protons, you go look at the Atlas V, which has actually sold a couple commercial, they use Russian RD-180 engines. This is the commercial approach. And actually, if you go outside of aerospace and you look at some other industry, it's even much broader. And I just use one example, the personal computer industry. You got the screens come from Japan, the RAM comes from Korea, the integrated circuit boards come from Taiwan and more China, and nobody cares because this is how free markets work. And we believe that's the way this industry needs to go in order to be successful. And if we create a Fortress America with trade barriers, it's going to hurt our nation, and it's going to hurt the industry ultimately. Because we will never be competitive with those people overseas by putting up barriers. Next slide. So what's next? And this is my final, and a lot of you have had questions that come up to me. Basically, we're still offering ISS cargo delivery to NASA. They've changed their mind once. We believe they'll change it again. And I want to make this clear is, there's no, as a business, we don't get upset at NASA. They weren't buying what we were offering, and the customer's always right, as a business. So, but we believe they still need ISS cargo. In fact, they're buying it on progress. And they're going to need it more as we get closer to the end of the shuttle. Okay, and since COTS is evolving away from ISS cargo towards crew and other things, and industrial development, okay, we think that NASA still needs it, and we're talking to them about it. Other space services. We've done consulting work for other companies. We are developing new business solutions. One of them was talked about yesterday, was Lunar Express. We have a patent pending on that. As an on-orbit safe haven. We have many other solution concepts. It really depends, since we want to be customer focused, on what a customer wants before we spend too much time engineering a solution. But we have lots of concepts and solutions. And we're also getting into support services, engineering, project management, government affairs. And we'd be interested in talking to any of you if anybody has a need we think we can solve. We're talking to some of you already, and we've actually signed some contracts. But that's the end of my presentation, and I'd be happy to take a few questions if you have. Joe Gillen.
You mentioned looking at an all-U.S. cargo path. Does that mean you're looking at another architecture aside from Progress, or what does that mean?
Oh, absolutely. If once another spacecraft gets certified with ISS, our proposal is to turn it into Tug and make it even more efficient as a cargo delivery system. As I showed, we're more efficient across all launch vehicles. Why not turn it into an intermodal system and get an instant bump of 30 to maybe, depending on the system, an average of 30% increase in cargo delivered for every launch.
Is there a Tug being developed by U.S. industry?
Talk to the COTS companies. A number of them are developing spacecraft that are basically, think of their Progress, you could then turn them into a reusable Tug like we were doing with the Progress. The CEV is another system that could do that. Dave Hunson.
Yeah. Chaz, how are you guys keeping, this kind of relates to a question yesterday, how are you guys keeping CSI as a necessary, non-expendable part of the critical path for anyone wanting to implement any of these proposals? Because, your Russian friends, for example,
right,
you mentioned yesterday, could think that, well, we could either go off and do most of this, we could even go and reform most of their team. How are you guys part of the critical path? How are you keeping yourself?
Well, one thing is a patent, okay? Yeah, some people would like to go recreate it, but they'd have to deal with a patent. Second is we have more knowledge about this system. It costs them something to overcome rather than partnering with us. Also, you can't just, the United States NASA has to buy from a U.S. company under U.S. law. So you can't just be a foreign company like the Russians and offer to sell this. This gentleman over here, any more questions? Thank you.